Okay, good afternoon, everybody. Rangarajan, you unmute, you interact with me, right? For today class.
Okay, sir.
Okay. Can you see that pane window with the text?
Yeah, it's visible, sir.
Yes. Okay. Now, the last class we discussed about how to construct from NFA to DFA. Now, we are having an algorithm for epsilon closure as well as subset construction. Now, we are seeing that one as in the previous problem. Here, we are having now the zero state. Right? Zero state. Then right. Here, we are having now 0 to yeah, 0, 1, 2, the epsilon. To 4, 3, 4, and then we are having now 0 to 7. Is also 3, 4, 5, 6, and 7. So, 1 minute. Someone is joining. 1 minute. 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 1 Okay. Is it visible, Rangarajan? Rangarajan?
It's visible, sir. It's still visible.
The diagram also visible, right?
Yeah, sir.
Yeah. Now you are going to start with the epsilon cos of 0. Right. Here, now we are going to see that epsilon closer of the 0. Then how do you start with that one? As here we are giving 0. 0 itself. So epsilon closer of 0. The last class we discussed about that. How do you find out epsilon closer of 0? Where we are having a 0 itself, and then we are having epsilon. We are having epsilon h 0 to 1, then 1 to 2, and 1 to 4, and then we are having now 0 to 7. Now we are going to implement these steps by a algorithm. How do you do that one? We are going to see. Right now, you see the algorithm computation of epsilon cluster of 0. So we are going to see that computation of epsilon cluster of 0. Right, computation of epsilon cluster of 0. Here, first step is push all state t into stack. All state t into stack. That is all state means here epsilon cluster of 0. So now we have placed the 0 into the stack. So here we are having now the stack. So you are having now the first state is 0. So that epsilon cluster, this is t. Right? In the t, we are having only one state, 0. So the first step is here. We are having now push all states in t onto stack. So we are having all state. Here we are having only 0 state. So we are pushing now that one into 0. Right. Next step is, second step is, we are having now initialize epsilon closer of t into t. So in that epsilon closer, the first step is right. The first step is you have to include 0. Then what we have to do is, right, now while stack is not empty, now the stack is having 1 0, while stack is not empty, so in the stack we are having now 0 easily, right? Now pop t, so you have to pop t the top element, so that one is in the stack we are having currently, now we are having 0, so you have to pop the t, right? Then half of the stack. So you have to remove the 0 from half of the stack. So you have to take out that, right? Take out 0. And then each state u. Now you note down that one. Each state u with h t to u by epsilon. So what all is t to e by u is here 0 to 1, right? Then 0 to 7. So these two states, right? So that is here we are having now t to u. So each state u is here, the u1 is 1 and u2 is, right? So that is each state for each state u, that is u1 and u2. Here we are having now u1, u2, that is 1 and 7. 1, 7 is with h t 0. So 0 to 1 as well as 0 to 7, we are having now a labeled epsilon. So this is 0 to 1 and 0 to 7. So we are having from 0 by first direct epsilon, we are having 1 and 7. Now 1 and 7, what we have to do is, if, see that, if u is not included in the epsilon cluster, so epsilon cluster currently now only 0 is there. So this 1 and 7 is not included, you include that. 1 and 7 is included, and also push 1 and 7 onto the stack. So add u, this one is add u is 1 and 7 to epsilon cluster of t. So this is epsilon cluster of t. This is epsilon cluster of t. epsilon closer of T. T is 0, epsilon closer of 0 is 0 and 1 and 7, right? So 1 and 7 we are including. Now, here what you have to do is, you have to push U. So 1 and 7, U 1, comma 7, push onto the stack. Now currently the stack is pop out 0. So we are coming in the stack, we are pushing now 1 and 7. 1 and 7. Right? Now we'll go for while loop. You are continuing now. So while loop is that while stack is not empty. Now the stack is having 1 and 7. So you have to pop 7. You have to pop 7. Now to the 7, there is any edges are there. Here comes 7, there is no epsilon edge. So you are removing that. Next we are going to have that one. Then once again the loop is repeated for second element. So you are pop out 1. So for that 1 we are having now the epsilon edge. So from 1 we are having now that U is U1 is 2, U2 is 4. 2 and 4. Now from the state 1 we are having now 2 and 4. So the 2 and 4 is pushed into the stack and also include in the epsilon cluster. So U is currently now U is 2 and 4 from 1. So U is 1. Then from that U we are having now 2 T is 1. T is 1 and you are 2 and 4. You are 2 and 4. So from 1 to 2, so 1 to 2 we are having the epsilon h and 1 to 4 we are having epsilon h. So you take this 2 and 4 as U and you have to add in the epsilon closer of T. Add epsilon closer of T and as well as you have to push 2 and 4. So you have to push into the stack as you are popping out that 1 and 2. Now we are having 2 and 4. Now you have to one second and pop out 4. From 4 there is no epsilon h. Then pop out 2. There is no epsilon h. Then the stack is empty. We are completing that epsilon closer. So this is the case of epsilon closer. Right? So this sets are epsilon closer. Can you understand now? Once again, you want to explain that one.
Once again explain, sir.
Once again explain. Okay, now once again you reopen that one. I'll save that one. Right. Now, once again I'll draw the diagram and explain that. Anybody is not yet joined now? Somebody is coming now? 1 minute. I'll come back. I'll admit Satvika. Anybody else not yet joined? So how many number of students are joined now? Only 48. Okay. No issues. We'll see that. Sure. Right. Now, we are going to start once again. We'll see the diagram. Once again, you see the diagram. Already we have drawn the diagram is 0. We are having that epsilon. And then we are having 1. This is we are having now epsilon. Here also we are having now epsilon. This is 2. Right? Then here we are having 3 by A. This last class we drawn the diagram, right? So I am directly drawn that one. A, B, and then we are having now this is epsilon H. We are connecting now for A R B, and then we are having A R B star. So you have to repeat that one as here epsilon H, right? So that is we are having now epsilon, and then here we are having now one more H we have connect now as epsilon, and then we go for this is we are having now that epsilon. Right. Now this is 3, 4, 5, 6, and 7. Then thereafter we are having now A as something. Now you are going right. Now we are concentrating on how do you compute the epsilon closure of 0? Epsilon closure state, right? So that is here now you'll see that what epsilon closure of initial state as 0. Now for the 0, how do you find out epsilon closure? So manually we are doing now as 0. Then from the 0 we are having epsilon closure 1. Then from 1 we are having epsilon closure 2. Then from 1 we are having epsilon closure 4. And from 0 we are having now epsilon closure 7. Epsilon closure 7. So we are having now 0, 1, 2, 4, 7 is epsilon closure of 0. The last class we discussed about my manual. Now by program or by algorithm, how do you write as the program? Now you see that algorithm. First step is we have to push all state in T into stack, right? Push all state T. So epsilon closure of the T. Here T is currently now we are having only 0. So now what you have to do is T onto the stack. First step is we have to push T onto the stack. So you take one stack. In the stack, we are having now, currently we are having 0. Right? We are having now 0. Right? 0. Okay. Second step. This is the second step. Initialize epsilon closure of T onto initialize epsilon closure of T. So what is the epsilon closure of 0? 0 into the that T is the epsilon closure of T. So on this, you first you have to include whatever the state here. So that 0 is here. Right? Now what I will actually you have to do is you are opening that while loop. The stack is not empty. Currently the stack is having 0. So the stack is having one element 0. So now what we have to do is pop T, small t, right? So small t is currently now that's 0. So in that stack we are having 0. You are popping out that 0. Popping out that 0. So that is we are considering as the states T. 0 is T. Now from the T, top of the element off of the stack. So you have to remove the 0 from the stack. That is off of stack. So you are taking that element in the T. So T equal to 0. Now you are taking out that stack, right? Now the currently stack is empty. So the T is 0. T equal to 0. Now what you have to do is each state if with an edge from T to U. T to U labeled E. So epsilon labeled H, right? So that is here. See, so this is T. Then U's are this is one U and that also U. So now you read that one. So labeled epsilon. So we are having now each state U. Now each state U with an edge epsilon from T. So T to U. T to U. 1 minute. Hello? Sorry. Okay. T to U. Check. Okay. T to U. So that one as we are having now T to U. That is this one. T to U 1 and 7. So now the U is 1 and 7. U is 1 and 7. 1 comma 7 is U. Right? Then 1 comma 7 is not in epsilon closure of T. So in that epsilon closure of T, there is no 1 and 7. So you include 1 and 7. So in the T, we are including 1 and 7. Right? So that is how do you do that one? Add U. The statement. Now you see this one. This statement, right? add U into epsilon plus R of T. So U is 1 and 7. So you have to add into epsilon plus R of T. Next, what you have to do is, we have to push U in onto stack. So 1 and 7 onto stack. Now currently we are having pushed the whatever that U element and pushed into the stack. Then you have to repeat the steps. So you have to go for in that while loop. So you have to consider the stack is not empty. So top of the stack is currently 7. So we are popping out 7. Now T is 7, right? Now for each state U with an edge from T to U labeled E. That latches is not there. So now you take 7 as T. From the T there is no U. That is no label with edge epsilon. So you no need to go what this form. This form please don't have any element. Now we'll go for the next step. So you have to pop the second next element. Top of the stack is currently now 1. So you have to pop the next element 1. So now this next element is T equal to 1. Now the stack is empty, T equal to 1. Right? Now what we have to do is T equal to 1, and then you find out that from 1 to epsilon h. So we are having 2 and 4 is epsilon h. So this is U. Now currently U is 2 and 4. So now current U is 2 and 4. U is 2 and 4. T is 1 and U is 2 and 4. Right? Then U is 2 and 4. Then you have to include that 1, 2 and 4 into T, as well as you have to push into the stack as 2 and 4. Right? Now you have to repeat the same steps. 2 and 4 is pushed into the stack. Now you pop 4. From the 4 that's no epsilon h. So you are going to consider further loop, and you pop 2. From the 2 also there is no h. So now the stack is empty. Now the algorithm is come to an end. So this is we are having into epsilon plus of 0. Right? So we add order it 0, 1, 2, 4, 7. So this is we are having now epsilon plus, right? Now this algorithm can be implemented by program. Can you understand now? Any one of you can have doubts, please ask me. You can unmute yourself, then you can ask question.
Yeah, got it, sir.
Okay. Next, we are having another algorithm for subset construction. Right. Another algorithm is we are having now subset construction. Right. Subset construction means, then I told you that one from the we are having now, you consider for all state, right? So here we are having now the subset is A, right? So currently now this A is 0, 1, 2, 4, and 7. A is 1, 0, 1, 2, 4, 7, right? Now from that one, then you have to find out the all subset construction, right? So you have to include all inputs into, right? Now epsilon plus of 0, S naught, 0 state, right? That one is. This is we are calculating from the previous algorithm. Epsilon closure of S naught. Epsilon closure of 0. Right? Epsilon closure of 0 is the only state in T state, right? So that is we are having the deterministic finite automata, we are having the state A. So epsilon closure of the 0 is this. The previous algorithm find out that epsilon closure of 0, that epsilon closure of 0 is this one. So this is we can consider as one state for DFA. So that is T state. This A is T state. Right? Now it is unmarked. Unmarked means you are not making a tick. So you have to consider this is unmarked. So it is not yet processed. So what actually we have to do is, from state A, you have to find out the transition by input symbol A. Then from state A, you find out the transition for input symbol P, right? Then you have to consider these are the sets. Then from that one, you have to find out the epsilon closure and so on. So now, how do you do that, right? Now, while there is an unmarked state in T state. So now currently one state is there unmarked as A, mark T. So you have to tick mark that T, A. So now we are processing that state A. So what? Then we have to put it now. This is tick mark, right? So A is now under process, right? Now what actually we have to do is mark T. So that T is A is we are marking, we are going to process, right? For each input symbol A, each input symbol A is in our problem A comma B. This is input symbol, right? For each input symbol A comma B. So A is a variable. For that A, first symbol is A and second symbol is B, right? Now what you have to find out, move T comma A. So that is T is A. So A comma A we have to find out first. A comma A. That is I write that one T tran of A comma A, right? So that's called move of A comma A. Move of A comma A. So the move of A comma A is giving now as 3 comma 8. Move of A comma A is giving now 3 comma 8, right? So that is 2 to 3 and 7 to 8. We are having a transition by A. 2 to 3 and 7 to 8. So 3 and 8 is, we are having now the move from state A by input symbol A, we are having a transition to 3 comma 8. So now we are getting now 3 comma 8 for this move T comma A. So for this move T comma A, we are getting now 3 comma 8. So move T comma A is giving the output is 3 comma 8. Now you find out the epsilon closure for 3 comma 8. Now we have to call the previous routine. Epsilon closure for 3 comma 8. Now previous algorithm is developing that one. So here we are having 3 and 8. First you have to push the stack into 3 and 8. 3 and 8 you have to push into the stack. Now you have to pop out that 8. So in the label we are having now 8. Then from that 8 there is no further epsilon h. So you remove that one, pop out 3. Then from that 3 we are having now that epsilon is 6. Epsilon is 6, right? Now you have to push 6 into the stack. Then from the 6 we are having now 6 to 1. Return back to epsilon. 6 to 1. Right? So 6 to 1. So we are having now 1. Push into the stack is 1. Then from 1 we are having now once again, then we are having now 2 and 4. 2 and 4. So this is the epsilon closure for 3 comma 8. So epsilon closure for 3 comma 8 using the previous algorithm, we are getting now that one as these are all the states. So that one has or that one 1, 2, 3, 1, 2, 3, 4, 6, 1, 2, 3, 4, 4, 6, 8, right? 4, 6 and 6 and 7 also, right? 6 to 7 also we are having epsilon h. So 6 and 7. So 1, 2, 3, 4, 6, 7, 7 is right? Now here what you have to do is this is not in U, right? So that U is, so this is U. U is A, B. This B is not included here, so you have to add one more state in the T state. Right? Now you have to put that this is repeated for another H, right? So A comma B or A comma B. So move T of A comma B, we are getting now that one as 4 to 5. Now epsilon closure for 5 is finding now, and it will take another set. So that state is C. So we are having one more state, C we are including now. They are including C state also. Now A state is over, then we have to take the B state. So almost unmarked state is there. You mark that one. You have to continue the same process repeatedly for finding the epsilon closure and so on. So this is for the subset construction. So using the subset construction, whatever that last class we manually do that one, using that algorithm we can do. Are you clear this now? Rangarajan or anybody else if you want to?
Yeah, got it, sir.
Yeah. Anybody else you want to repeat that one? Please unmute yourself. You can ask question. This should be somewhat interactive. Then only it will be useful for you. If it is leave days, it is a sleeping time, but you should not sleep. Please. Anybody else?
No, sir. We got it, sir.
Okay. Right. Right. Once again, I explain that one. Then only it will be clear. Right. If I may explain that one here, you realize the previous class, right? Then only you can easily understand now. Now, here what actually you have to find out as the first step is epsilon closure of S naught. S naught is nothing but the start state, right? So epsilon closure of 0. Now we are calling the previous algorithm epsilon closure of S naught is 0. So we are calling this algorithm, this the previous algorithm. The previous algorithm is giving the output as 0, 1, 2, 4, and 7. Now this is one state, that is A. We are taking it as A. That is the start state of T states. So T is a deterministic finite automata states. So in that states, deterministic finite automata states are the initially we are having A only. A only. A is this set. That last class we discussed that one. Right? So this A only, right? So that is we are having now A, right? So that is theta now, right? So that is we are having only one state. Initialize that epsilon closure. So epsilon closure is this one. Epsilon closure of A, right? So initially we are having A only in the T state. So initially we are having no A only in the T state. Now what we got? There is an unmarked state T in state. So this is we are having now unmarked state currently. So it is unmarked. A is there. It is unmarked. Unmarked means we are not making tick mark. So you have to take that unmarked state as initially. So you have to make a tick mark. So that is here. You have to make a tick mark of T. So T is now currently processed. A is we are taking now for the processing. Right? Now what actually we have to do is from the A for each input symbol. For each input symbol. So from the A, each input symbols are here we are having now A R B star A B B. A R B star A B B. Only two input symbol. A R B. So only two input symbol. So you take that one for each input symbol A. Here the name is A. This is a variable. The A may be either A or A may be B. So you have to take, you have to consider all input symbol. So first you take one input symbol. So you have to move A comma A. So that is I write it that one. Move A comma A. So from A by input symbol A, right? This is the function. So this function is returning now 3 comma 8. Returning now 3 comma 8 because 2 to 3 we are having a transition and 7 to 8 we are having transition by 8. In the NFA, right? So 2 to 3 and 7 to 8. So 3 comma 8, right? Now what actually you have to do? So we are calling in turn, we are calling the function. Now this is the case. Epsilon closure of 3 comma 8. So we do that one. Now you have to find out epsilon closure of 3 comma 8. Right? So epsilon closure of 3 comma 8 we have to find out. Right? Now this is previous algorithm is doing now. So we are from the 3, what are the epsilon closure? So how do you do that one? You have first you have to push the 3 and 8 into the stack. Then pop 8. So 8 is not already included. So you are in the T state, we are having now 8. Then from the 8, there is no epsilon 8. Then you take 3, right? So 3 itself, 3 to 5 we are having now, right? 3 to 5 or 4, 3 to 6. 3 to 6 we are having now. And so we have pushed 6 here in the stack. Then we have to pop 6. From the 6 we are having now 1 and 7. So you have to push into the stack 1 and 7. Then we have to pop 7. From 7 there is no epsilon h. Then from 1 we are having that epsilon h is 2 and 4. So you have to push 2 and 4. Then you have to take that one as in the list. And you have to pop 4. So from the 4 there is no epsilon h. From 2 there is no epsilon h. So you have to complete that one. So this is we are getting now in that one, right? So that is that u. Current u is this state, right? So that is 1, 2, 3, 1, 2, 3. What is that? Oh, 1, 2, 3, 4. Right. 2, 3, 3, 5. Sorry, I have 2, 3, 5. Right. 3. Then 1, 2, 3, 4, 6, 7, and 8. Correct? So this is considered as a new state, T state. So we are adding one more state here. Right? Now, this is we are having now T tran of A by A, it will go to B. In the transition table, you have to put now T tran of this A comma A to B. And then you have to continue the same one for next input symbol. So A by B, we have to move A by B. Move A by next input symbol B. So we are getting now that's 5. Then for that 5, you have to find out epsilon closure, right? So for that 5, we have to find out epsilon closure. Now this is a new state U. So you have to take that one as new state C is also included now. Now we are having a transition is A by B, it will go to C. That entry we have to put it in the table. And then we have to continue. So this for loop is over. Then we have to take any unmarked state. So that unmarked states are currently now B and C. B and C is there. So B and C is there. Now you have to take B as further process. So now you have to take this B. So for B, you have to consider all inputs in that. Right? So from B, you have to find out B by A and B by B, we have to find out. And after completing that one, we are getting for the new state D. So D also included. And then you have to take that D here. And then you have to take next unmarked state is C. You take that C. From C, you have to find out all transition. And from T, you have to find out all transition. You are having one more state E is coming now. Then from that E also, you have to find out all transition. And there is no further state. So you can stop the process. So that is we are having now the subset construction. Clear?
Yes, sir.
Yes. Now we can stop here today, right? And you try to solve that the last class problem, right? Then by Monday class, you have to solve that problem. If you are having doubts, then we will clarify on Monday hours, right? So whatever you are solving, then we will discuss that one and we can complete that topic.
Okay, sir.
1 minute. Here, now you have to give attendance in the chat box as your register number and name. All of you give attendance in the chat box with your register number and name. Yes, students, you have to give now your register number and name in the chat box. I copy the chat box as the attendance. Who is admitted now? Right. Whatever content now we have that one, I put it into WhatsApp. So you take the content into the WhatsApp, then you have to go through once again. Anybody is having doubts, you can ask. Otherwise, you can leave. If you are having any difficulties, you have to inform me. If you are facing any difficulties for attending online class, please inform me. You unmute yourself, you can talk with me here. Another 10 minutes is there. If you are having any doubts, you can ask. If you don't have doubts, then you put attendance and you can leave.